Testing. Yo. Testing. Testing. Yo. Testing. Holy moly, you're...
John Thomas?
Yes, sir, you're camping.
Bro, I'm not gonna lie. I might be the only person joining 2 days before,
Oh,
bro.
that's fine. Like, I don't care. I'm not doing it tomorrow, so that's not my problem. I'm just trying...
Yeah, like,
I do this to
my
be
problem.
nice.
Bro. Not my problem.
What? Yeah, I
It's not
know.
my private problem either, because I'm here with you right now, gang.
Well, I do this to be nice to people. I don't really need the studying, so...
Why, if you didn't study,
If I didn't study, I'd be fine. I haven't learned anything new this year.
you got 100 on the quiz?
Yeah. But,
So you're telling me that center of mass shit, like, that wasn't new to you at all?
well, it was new, but it took... Like, I learned it in class. It wasn't that new. It was just, like,
That's fair.
kind of...
Loki, can you just go over, like, some of the AP class
AP class, sir.
that I know you completed?
I think the YouTube stream quality is super crappy because I just noticed that.
It's okay, no one's watching.
That's okay.
My bad. That was a little rude. Yo, get Lippman in here, bro. We need bums. Yeah, Nico,
I'm
Lippman.
low-key not trying to have my YouTube account terminated.
Okay, so not Lippman, just Nico. Because, like, they gotta ask questions and stuff. I don't really have that many questions. It's pretty straightforward stuff. I just know that if I buddy, so
Yeah. Wait, I feel like I messed up the stream this time.
I'm just gonna tag any bum in chat to join, bro.
Yeah.
Connor definitely a little slow. Scowen probably a little. He's probably a little slow.
How do I even...
Hmm. Hmm.
Okay. Yeah, what do you want to do? Like,
You go like I don't understand some of like the
can I get out
tension,
of now?
the ranking tension shit. You know what I mean?
One sec. What did I do here?
That would
I
be
didn't
definitely
actually,
good.
like, do this one out, I don't think.
Wait, let me read it.
It's gonna be... Force of friction mixer. Oh, so it's just... Well, that's just... It just ends
The
up being
magnitude of the force of friction.
nonsense. Oh, sorry.
Wait, I don't understand that. I didn't read it.
I'll
You didn't
explain.
give me any time.
So it's asking, like, how much friction will be exerted, when it's at 10 degrees.
Mhm.
Um, the block starts to slide at 10 degrees, so that means the net force becomes greater than 0 at 10 degrees, greater than 0 newtons, right? So let me, according to the reference table, I think it's on here. Let me show you. Let's see. Damn, nothing's gonna work well. Okay, sorry about this.
L Canton 29.
Where do you see that?
Oh, I thought that's what you were logging into.
Okay, so according to the physics reference table,
My bad.
force of friction is less than or equal to mu Fn, right?
Wait, for static friction.
This either type of friction actually, but usually static, yeah.
Why?
Um,
But kinetic, I thought is that's already
well,
moving.
well, I guess yeah, kinetic wouldn't. But okay, for our purposes, static. It's less than or equal
Yo,
to this,
bomb
meaning
finally, bro. We
what?
finally got a bomb. So we finally got a bomb in this
Who? What?
VC.
Cool. So what I
Like
was
the
trying to
worst student on the
what
left
I
list,
okay,
bro.
chill out. So what I was trying to explain is that F of F, force of friction, is less than or equal to mu Fn. So that means it could be zero. Like given that there's no other force, it would be zero. So in this case, at 10 degrees, it starts to slide. So if we were to draw like a free body diagram, so, uh, I can't draw a triangle. That's a whole different issue for a different day. Let me actually put this.
Why don't you go back to geometry class game?
Yeah, okay. So this is 10 degrees, but that's not really relevant. So it's saying for this block at 10 degrees, it starts to slide. So that means F net, like F net parallel, really, if we want to be specific, is the magnitude of it at least is greater than 0 newtons, because that means there's an acceleration, meaning a change in velocity, right? So it's no longer at rest. So if we look at F net, right, I'm just gonna write F net. It's gonna be equal to the force,
MG sign.
since it's sliding downwards, the force in the positive direction is going to be force of gravity, which is going to be equal to, if we draw, well, Fg is this way, Fg. The force of gravity is the parallel, which I can't draw, but
No, no, I get it. I
yeah,
get it.
okay, Fg, you get it?
Wait, can Connor? Let me make sure Connor
He's
gets
got a
it.
request. So F net
Connor.
is mg sine theta. And then it's going to be minus the force of the normal force, which is Fg cos theta, um, times mu s mg cos theta.
So like on ramp problems, the trig is the opposite of like normally, right? Because the angle's from the top.
This is the sine, the opposite. This is the cos. This is the hypotenuse. The hypotenuse is gravity
Right, but like
gravity.
traditionally we think of the angle from the one that's like not that
No,
from not that
normally,
side.
well, when we
Really.
do an initial velocity for a trajectory, right, we will have something like this, right? This would be like v0, then this is v0x, this is, or aka v0 cos theta. Then,
He's raising his hand.
all right, yeah, one sec. So, yeah, you can speak. So it's 0 newtons. Real quick to solve this, if we divide out all the stuff, mu s cos theta. Oh, what was it asking? Okay, just the magnitude of the force of friction. So we don't actually need to write all this here. We can just leave this as force of friction, FF. So if we just rearrange this, we get FF equals mg sine theta.
Because okay, so the magnitude of force of
And
friction.
the reason that it's not this answer that I selected, right? The reason this is not the answer is because the equation shows us that the force of friction is less than or equal to mu Fn. So in this case, this is Fn, this is mu. It can be less than this because it is actually less than this in this case. So this wouldn't be the appropriate. This would only be when it's equal.
Wait, but isn't mu since mu is less than one, it would be that is less.
Sorry? Wait, since
Mu
mu
is
is less
less.
than
Oh
one.
wait, no, because cos.
It
Wait, hold
doesn't
up.
say what mu is. But
Yeah, but we okay, but so we can't assume it's less than one because technically there's things that are more than one.
um yeah, I think this is just the most appropriate answer because you use that when you find your normal force.
I mean, I get why that's like equal, but like I don't really get what it's asking.
It's just asking what's the force of friction. When we rearrange this, we just get F of F is equal to mg sine theta.
F of okay, so we're not including. So okay, I got it. So mu fn is equal to that though, no?
Um, what? The mu Fn, yeah.
Mu fn is not equal to mg sine theta though. It's equal to mu mg sine theta.
Mu mu Fn is equal to mu m0 g cos theta. But
Sorry, cos. Yeah, exactly. Wait, what?
Look, the magnitude of the force of static exerted is equal to the component of the
Oh,
velocity
but
because the
I'm
net
so
force
lost
becomes
now.
zero. Well, incorrect. This answer could be obtained by the force of friction must be the maximum possible value of static friction exerted. Okay.
Connor will.
Okay, so basically, look, our equation saying that the force of static friction can be less than or equal to mu Fn. So this would only be true if we know that mu Fn is at its maximum. It's like the maximum possible. Mu Fn, its job, like this job of friction is literally just to cancel out or oppose other forces. But it can be, let's say the other force is lesser, mu Fn will be lesser because it only has to be equal and opposite. But at a certain threshold, it can no longer like exert that much frictional force. So then it just, you switch to kinetic friction. So what this is saying is that it could technically be less than this, but it's still sliding. So, like, that's assuming that it does reach, the static friction does reach its maximum value, which we don't know that it does. But
All right, so but we're looking at it that it's
well, we just
balanced,
look at
so
the
we
F
just
net, right?
we
We
just
have
know that
force.
mg sine theta is equal f net is 0, right?
Yes, it's 0 newtons because that's when it.
This is like
That's
before it moves. Oh,
this
it's
is like the
before it
instant
moves.
before it starts moving. It's 0 newtons. Then immediately after it well,
So like if the if the friction force needed to break through static friction was like 1,000 and you put 30, it would only put 30 back, not
exactly,
1,000.
exactly.
That's
So
basically what you're saying.
yeah,
Okay,
like so if
gotcha.
there's yeah, right. So if we had like a block on a surface and we put 30 newtons, 30 then yeah, it would give 30 newtons back. The force is
It's not like the friction would bounce back on you or whatever. It'd be equal and
no.
opposite.
But and as we increase this, it would still this would increase until it reaches its threshold, which is why the equation says less than or equal to.
All right, that makes sense.
Yeah.
Mucho.
Which one? 8? Um this is what you wanted to do? Okay, it's given an initial velocity up. Let's see if I can draw a triangle. I can't draw a triangle, but it corrected it. Okay, 53. So I'm gonna use my like, actually no, we don't have to do that. Just real quick, so you know, cos of 53 degrees, we're just gonna approximate it, is, what is that? 3/5, and then sine of 53 is 4/5. That's what it wants you to use. That's in your reference table, so like, those are just commonly known angles. 53, yeah. Sine is 4/5, cos is 3/5, so that's what you're expected to use there. As it is sliding, okay, it's slowing down. Okay, it's sliding up the incline actually, so the velocity is this way, v is that way, but it's slowing down with a constant acceleration. So okay, there's given we're given mu k is equal to 0.5. So if we look at the block this way, right, we're going to have two forces acting this way because it's actually moving upwards, and friction's an opposing force. So we're going to have F of g, gravity is going to pull it downwards as it's still going upwards because it has an initial velocity, and friction. They're both so F net is equal to, what's it asking for? What is A? Okay, so F net, given Newton's
What
second
question are
law,
you doing right now?
you asked for 8, I believe, right?
No, I didn't, bro.
Okay,
I my bad. I wasn't even listening, but it is low-key a hard question.
so that's why we're doing it.
Okay, but like I didn't hear you because like my dad was asking me
That's
something.
fine. So F net is equal to ma. Newton's second law, F equals ma. We don't need to know mass actually, but this is also equal to what we have. We have friction, we have force of gravity and force of friction opposing this velocity. So they're actually both in the same direction because the velocity, because friction opposes velocity, not other forces per se. But usually when we have one force, it's going to cause the velocity to be in that direction. So then friction would be in the opposite direction. So friction opposes velocity, which is important to know. Alright, so we have FG, which is going to be using what we've learned from like previous stuff. That's going to be mg sine theta. Okay, and then so this is FG, and then plus FF, which is mu k, also known as 0 0.5, 0 0.5 mg cos theta. We're also given theta. we'll worry about that after. All the m's cancel out, which is really nice. So that's solving for a now. So we have a equals, I'm going to plug in 10 meters per second squared
Hmm.
times the sine of 53 degrees is 4
4/5.
fifths times 4 fifths plus 1/2 times 10 meters per second squared times the cos of 53 is 3 fifths. So when we simplify this, which I'd really rather not do,
It's
we
just
get
8.3, no?
what? It's
Wait,
8
hold up.
8 meters per second
Sorry, my bad.
squared plus
How's that's not right though. Oh wait, yeah, my bad. Wait,
that's 11 meters per second squared.
why would how's that annoying to simplify?
It's not. I just don't like doing simplification. It's like I'd rather plug it into a calculator. Um, so that's 11.
It's okay. That's the only points that Connor.
Yeah.
We're all different.
Okay. What do we want to do? Zhang, you got something?
We do
Or Connor?
7.
Speak out, Connor.
Yeah,
He
you
said,
can
"Can we
also
do
say you
6?"
can
If
paste
you
it in the
can hear him,
chat like an image of it if you'd like.
he said, "Can we do 6?" I
He
think.
said that. We already did
Mic is so
6.
low. His mic is mad low.
Connor, you wanted to? Can you just write it in the chat? We did do 6 already. Yeah, I'm
Speak
not
up,
actually.
bro.
I can go over it again real quick.
No, he
Just
said 7. My bad. He said, "Can we do
he
7?"
did that on purpose, didn't he? Really,
Huh?
6, 7. Okay. So what this question? I'm skipping straight to the bottom because the setup's generally the same between all of them. Okay. What is the maximum acceleration the small block can have without slipping? So without slipping means if we look at relative motion, without slipping means the velocity, the net or the relative velocity is 0. So it means the velocity of little m 0 with respects to big M 0 is 0. So it looks like if you were this big block, it would look like the little block's not moving. So the relative velocity is 0. So
Oh,
that
wait,
means
what?
that what? So if one
They just
block's
move
not
together.
what's up?
They just move together,
If they're
basically.
moving together, it looks like the relative velocity of one block observed from the other is 0. It's like if you were this big
Okay,
block, it would look
gotcha.
like the velocity of this little one 0. Okay, so that also means that the relative f net is 0. That doesn't mean the actual f net is 0, but the relative f net. So for this one, I don't know that I did this correctly originally. Um, let's see. So there's two forces acting on this little block, this little m0. We have FG parallel and so
Mm.
FG parallel is going to be this way, like if it was on a slope. Parallel, and then the other thing we have to consider is that it does have a force of friction, and what is this? Okay, it's pulled. They are accelerating up the ramp, so that means that the force of friction is going to be opposing that movement. So the force of friction is going to be this way as well, I believe. I might be mistaken. I gotta.
Wait, what about M? Oh wait, no, never mind. So there's no friction between M0 big and little.
Actually, I'm mistaken. So there is friction between the two blocks. That's where it's coming from. So the force of friction, if you look at it this way, right? This it's attached to the big block, right? So the big block is being pulled first. It's being pulled by the string, and then the friction of this big block is kind of pulling the little block in the opposite direction. So there is a force of the little block is exerting a force of friction onto the big block to the right because the little block wants to stay there. The little block wants to stay where it is, but the big block's being pulled left, so the little block resists and pulls the other block right. But the big block is saying, I have friction, so it's pulling the other block to the left. So it's force of friction here. Now we can just solve this F net. It's the maximum acceleration without slipping. So, alright. So that means F net relative, like, this is a weird way to do it. There's multiple ways you could do it. Is equal to 0 newtons relative to the other block, I believe. Um, so we're gonna have to use static friction here because not moving is generally means static friction. So that's gonna be our force of our normal force is gonna be this way down. It's gonna be Fg perpendicular times what is that, mu s?
Wait,
Okay.
FG perpendicular.
Yeah, because that's normal force, right? If we look at this,
Yeah.
this block is pushing into the bigger block, and that's gonna give it its normal force, which is
But the
going to
normal
this.
force of there's two different normal forces, no?
We're looking
One
at the
from like
we're
the
just
ramp and
looking
one
at
from
this
the.
little block. It's exerting a
Oh,
normal
okay.
force into the big block, and then the big block exerts it back outwards. So it's
Okay.
up to the right. And so that's gonna be FG perpendicular times mu s is gonna be the force of friction. So let me rewrite F minus FG parallel. Okay. And this is gonna be equal to
M0G
FG
cos theta.
perpendicular, which is m0g, it's cos theta times mu s minus m0g sine theta. Yeah, this question, the big lock there is like not much to it. Okay, so it's asking for acceleration, so Newton's second law, F equals ma, cancel out the m's. It's really m0a here. M0, so we get a equals g. Oh, sorry. Let me rewrite it in the way they wrote it. Mu s g cos theta minus g sine theta. Theta 0 rather. Okay, so that's how that one's done. Um, yeah.
Wait, but if it's saying there's no slipping, does that mean that big M block has the same acceleration?
Yeah, that means they're both accelerating at the same speed because they have the same velocity.
So like in theory, solve it for big M and you still get the same thing.
Um, you're gonna get the
Oh
same
wait, yeah,
thing.
because the masses cancel out, so
And
it wouldn't
we
even
can
matter.
actually, well, because look, they both exert the same force of friction on each other. If you want to look at it this way, if we want to redraw it, right? Um, M0. So this has a force of friction exerted this way from the big block, right? From big M0. That friction's from the. You got to think the big block is going to the left and upwards, and it's rubbing on the little block, so it's trying to pull it
Whoa,
along,
we
dragging it
don't
with
do
it.
that, JT. We don't do that.
Okay, that's fine. But then likewise, the little block is trying to slip downwards and to the right, so it's trying to pull the block under it to the right. So the big block does actually have a force of friction going down and to the right, but that's from the block on top of it. And that's technically also from the surface under it, but like it doesn't seem to matter in this question.
So basically, I'm cooked on the test tomorrow or
No,
Thursday.
I don't even know that he would like well, I'm not gonna say that he wouldn't put this in.
What I'm nervous about, honestly, because we've done plenty of like multiple choice. Like is it gonna be like AP style FRQ, right?
I would assume so. There's no
Do you
experimental
think
design on
do you
this.
think he's gonna give us a practice tomorrow for that?
But tomorrow we're doing it. Oh
No,
no,
Thursday.
tomorrow's not. He can't give exact AP questions. Brian,
Yeah, but like he's gonna kind
need
of
to speak
get
up.
like because he hasn't given us an
Wait,
AP
when's the
FRQ.
test?
The test is Thursday, but this is like just I
This
would
Thursday?
yeah, I'm not doing it tomorrow because I have a lot of work.
What the fuck? Wait, what?
Oh man,
Can we just have one?
it was a quiz. Now we have a test. Friction's what's added on. Also like this is being live streamed and saved to the internet, so like
Oh,
I'm gonna get my
interesting.
Hey, can we not swear, please?
Okay,
it's not
my
that's
bad.
not even bad compared to what Isaac said. So
Is that on YouTube?
yeah,
That
it is
one?
on YouTube. It's unlisted though.
I mean, I feel like if YouTube
Uh,
has like auto moderation, they could probably detect that.
Oh,
No,
it's still on.
oh
It's
dear.
still on there. I listed it as not for kids.
Well, I
So
mean,
it's okay. I'll
no,
be
it's
sending that
like
video
past
to
the
every
first
college
minute. It's
Isaac
fine.
applies to.
It's past the first minute. It's fine.
do we want to look at something? I don't know. Damn. Let me see.
Can we do like?
Why does this say it took me an hour and 10? Oh, it's because I closed my
Wait, hold
tabs.
up, John Thomas. I got a question for you. I don't have like a question, but like
Yeah, yeah,
the concept
yeah.
that you could go over. I think we went over it last time, but I didn't really understand it on the test, and I got that question wrong. It's about like the tensions, like ranking them and shit, and like where. I don't even
Okay,
know.
so you want to do like the ones where it's like they all have an acceleration of a?
I think it was like a A. It was like A and C. Do you remember that? There was like A, B, C, something else on the test.
Was it? Let me see. Oh wait, the quiz we just got back.
Yeah, yeah.
Um, I think I have
Wait,
it.
did he give? Wait, he gave us the quiz. I
Yeah.
forgot. Like he
Wait.
let us keep it.
I think I have it. What question?
It
Oh,
was.
ABC
Is it?
question two.
Yeah.
All right, let me
I don't
just.
know because it might be, but it was something with tension. I don't remember. And I just don't understand that whole concept.
I think I'm gonna post it in the Discord. Tell me if this is the right one, and then I'll go over it. 1 sec.
My name is red, my collar's blue.
Is that it?
No,
No.
that's not. Wait, is it? That's not it. But can you do that one too?
I can do. Oh, I see what you're saying. Question 8. I'll do question 8 afterwards. Okay, yeah. Give me a sec.
I think I don't know. What do I do for that one?
Okay. So question number.
Yeah, it's definitely 8, but do 2 as well.
Okay, 1 sec. Yeah, question 2. Okay. Okay. So
I'm not gonna lie, JT. I've learned more from you than Huang this year.
well, that's because he's not given the opportunity to teach because they don't stop talking. It's not his fault. Okay. So, okay, 1, 2, and 3 are initially at rest on a frictionless surface as indicated to. Okay. So, something interesting about systems, right? A system, you can kind of treat 3 blocks like a system if they're moving uniformly. So, like these blocks, we know they're always all going to be like touching each other, assuming there's no friction.
Yeah, I definitely got this one right. I
Assuming there's
just,
no
what if
friction.
there was friction?
Well, that would affect it because that means one block would keep going for less time, possibly keep going for less time than the other. So they would start to spread out, and that would like you couldn't really treat it as a system because they
So
felt the forces of friction.
how would we solve it?
Well, for that you would have to look at their current velocity, and then you'd have to set up. You would say so you could use like whatever when the force stops being exerted, you have whatever that velocity is equals like v0 squared plus 2ax. You could use this equation.
Oh,
This
so you
this
just
would be ff divided by mass to get your
wait.
a.
So it's like that one. There was one problem. Like it's kind of not that, but like you had to use this equation. It
And
was
your
like
and
x
your
is
ending
2 and
velocity would of course be
velocity is
0
4 or
because
whatever.
0 meters per second because that's when it stops. So you would have
You
to
know what
use
question I'm talking about on the AP classroom from
just
today,
no, but let's do this
where you
one.
had to use that equation.
This one's really straightforward because
Yeah,
when
no,
you
this is
move
easy. I think I get it. It's
uniformly,
just like you just add the masses and you
when you
divide.
pretend it's a 6 kg block, you want it to
It's just
move.
F equals. It's just F net equals ma.
Yeah,
Literally, man. And m is just the
and
summation of the masses.
you wanted to do the other one, right? Question 8.
Yeah, 8. No, 8. Yeah, 8. I think I understand 8 as a question. Can you just go over like the conceptual shit behind it?
Yeah. Okay. Um. Okay. Sure. So, which string must
Mhm.
be the strongest? So he's really just saying which string is having the most force exerted on it. Okay. So let's look at this. Since these blocks are all attached to each other, we know that they're all gonna have, right? They're all gonna have the same acceleration. Can we agree on that? Right? They're all gonna have the
Wait,
same
what?
since they're all moving uniformly. Like the strings are not stretching or anything for our purposes,
Okay, yeah,
for
yeah,
our ideal
for
case.
sure, for sure, for sure.
So, so what this tells us is that they each have the same exact acceleration. Okay. So let's look at this. Let's look at this 3m block. We're gonna draw a free body diagram. What forces are acting on it? There's no friction. So what forces?
Force of tension, normal, and gravity.
Okay, but normal and gravity cancel out, so we're only going to
Right.
look at this as a one-dimensional problem. So we're just going to ignore normal and gravity because, like, we can just infer Ft.
So gravity doesn't exist in your book,
It
and
does,
normal
but
doesn't
since you're not
exist.
working with friction, it's not
All right, I'll
relevant.
keep that in mind on the test Thursday, and I'll let you know how that goes.
So Ft is our FTA. I guess I'll do TA for A. So, and we know, let's say, we know this entire thing has an acceleration, accel of A, right? That's gonna be your acceleration for the system. All 3 of these are
Mm-hmm.
accelerating at A. We can agree on that since the strings aren't breaking or whatever. So that means that
If
so
you
that means
insist.
FTA, right? FTA equals 3m mass is 3m times the acceleration is A. Okay?
I can agree with that.
Yep. Now we're going to treat these 2 blocks, we're going to treat them as a system. So we have 3m, this rope, 2m, and then FTB. So let's look at it this way. We can look at it like this, but also because they're moving together, we can look at it like this. these are the same. FTB.
And the tensions between 3 and 2 cancel out.
That's exactly, these would cancel out. Yeah. Okay, so we can look at it like this. So FTB equals 5m, and just like everything else here, it has an acceleration of a. So FTB equals 5ma. Now, if we do that again with a, b, and c, if we unify these as one block or just treat it like separate, F here is, or FTC is going to be pulling 1
6.
meter
Okay.
plus 2 plus 3, so 6 meters. So FTC
6
equals
meters.
6 meters A. So now if we compare
Hey, why are
these
we
three
calling
bodies,
M meters?
what?
Why are you calling M meters?
M is mass. That's the name of the masses. That's what it says.
Yeah, but why do you say meters?
Meters, my bad. Sorry. 6 MA. So if we just compare these, FTA is 3 MA, FTB is 5, FTC is 6 MA. So like assuming that mass and acceleration are positive, which they're going to be, we're just looking at the magnitudes. C is going to be exerting the greatest force, greatest magnitude of that force. There's a 6 as the coefficient, meaning it has to be the strongest not to break.
So what would how would you find the tensions on like 2? Like if you had just the system of the 2M.
Just the system of the 2M.
Yeah.
So like this. Um,
It would be like TA minus B or whatever
you couldn't find these individual. You would have FTTB,
equals
and
2MA.
then you would have FTC, because like these are equal and opposite pairs, right? So these are both FTC. Oh shoot, I messed
Well,
up.
you mean A, right? You mean A.
FTB, FTA. Yeah. So like this, there would be on both sides of the rope there would be an FTA. So
So
those would cancel
in
each
the
other out.
example before, we can cancel, but here we can't.
Well, yeah, because here in the entire system, when we look at this as an entire system, we can actually write this out as Fnet equals, right, this is, so let's say the right is positive, right? This is positive. We'll start from here. FTC, that's going to be positive because it's pulling to the right. FTC minus, this is pulling to the left, minus FTB plus, this is pulling this tension here is pulling this block to the right, plus FTB
Wait,
minus FTA. This is pulling the 2M to the left, so minus FTA. It's in the opposite direction. Now FTA here, force of tension A, is pulling the 3M to the right, so that's positive. So what we get is a bunch of cancellations. Fnet equals FTC. So what we can do here is FTC is this thing here. We can turn these three into a single system, just a 6M block. And 6M times A equals FTC. So, like in it, that's how tension works. But when we're just looking at one of these, when we just look at this block, right? We're only looking at how this rope pulls it this way. We're not going to be looking at how the rope pulls the other block this way because it's not relevant to the system that only consists of this block. It's only this block and the things that interact with it. Technically, the string pulling this block to the right does not have anything to do with this system here that only consists of the 2M block. Like, systems are confusing, but when we draw the entire thing as one system, we need to have all these cancel out. But because these free body diagrams are a single part that constitutes its own system, so they wouldn't cancel out because these are different
wait, I have
systems.
another question based off this. It says like the coefficient of friction between each block and the surface is the same. So are we assuming that Fn is just that we're assuming it's a 6 mass together again there, right?
Sorry?
Like we're assuming for mu Fn that Fn is just mg, but like 6 mg.
Yeah, something like that. It doesn't really matter. So like we could rewrite FTC minus mu 6mg. Then we could rewrite this minus mu 3mg.
It's still
But
they
this is
all
not
have
going to
that
achieve
same.
anything for us when we compare it. Yeah, because it's the
Okay,
same
gotcha.
force of friction. Now, if it said something like, if the question asked something like, if it said rope C could only pull a maximum of 30 newtons, and it said, would it break? Then you would have to actually account for what is the value of friction, and will it exert enough force to cause the string to break? So that's when you would have to worry about that. But because these are just comparisons to one another, it's not necessary.
All right.
Yeah.
That's fair. Was there any other like hard ones on this quiz?
I
That
can't
wasn't
think
hard,
of
but
any.
like, was there any
Let me
hard
see.
ones?
Oh yeah. A lot of people got real quick. Question 4. A lot of people got this wrong. This one's kind of important to understand conceptually, so I'll go over that.
Imagine getting 4 wrong, Connor.
Bro, a lot of people, almost everyone.
Yeah, bro. Connor got 2 right. Like 2 questions right.
2 total. Why are you
Like
shaming
multiple
me?
choice. I'm not shaming him. I'm just saying like maybe it's time to go to physics regular. Like maybe. And he knows that comes from a place of respect, right, Connor?
Of course, man.
He's okay. People do worse than him, believe it or not.
Like
Bro,
actually,
getting a 40
three
pre-curve is crazy, bro.
What?
is actually what? Nothing.
40 pre-curve is diabolical.
Pre-curve.
Yes, bro.
Okay. Let's go over this question. Really important thing
At
to
least it wasn't
understand.
after the curve.
Okay. All right. F equals ma. F equals ma. I want to get this over with. And f, it gives us f is a function of t. So all right. So f is a function of t, and it says that f of t equals negative 3t. All right. And at t equals 0, the velocity is 4 meters per second. So that's telling us v0 is equal to 4 meters per second. Okay.
Bro, I
So
just brute forced the graphs for this.
all right, just yeah. I'm gonna explain it though. So force equals ma. So 3t equals ma, and we're given that the mass is 6 kg. So 6 kg a. So this is actually finding us. It's actually 6 kg a of t. A is a function of time. So what this gives us is a of t, a as a function of time, equals f of t, t over 6 kg equals negative t over 2. Now, this equation, the mistake most people had was they used the kinematics equation here, vx equals v0 plus, or v final equals v0 plus at, right? V final equals v0 plus at. But this function, this is actually saying, a is a function of time, where a is some constant, or we could say like a of t, where it's some constant a, like a rational number or something, right? So that's actually, so if we integrate a of t, right? If we integrate a of t with
0.
respects to dt,
Oh, wait, no.
just
AT,
you have
yeah.
to understand this. This is okay. We're gonna get something like, since a is a constant, we're gonna get at plus c, because we're integrating a constant with respects to time, so we multiply by time once. And then plus c, where c is going to be v0 in this case. v0. Okay, so that would give us that, yeah, at plus v0. So that works if a is a constant. But in this situation, what we have here, a of t is not a constant. It's not equal to a constant. It's equal to a function of time. So it's equal to negative t over 2. So if we want to find vf, we have to integrate a of t with respects to dt. I'm going to move this all. I forgot to move half of that. That's nice. And that. I can't move things today. Oh my god. Okay. Let me just clarify. Okay. So we have to integrate this. And a of t is negative t over 2. So when we integrate this, v of f is equal to negative t squared over 4 plus some constant c. But it actually gives us, when we integrate an acceleration function, it's gonna give us a velocity function. So this plus c is gonna be some y-intercept or something that represents initial velocity. So it actually gives us v0 is 4 meters per second. So we have that. Okay. And what the question's asking for? What is the question asking for?
It just wants the graph.
Okay, so the graph. So this is v, right? This is v of f. If we wanted to get the graph, what we could do is we could integrate this once more. V of f v as a function of t, really. V of f is only at the end, so it's like v of t. So we could integrate this once more. I'm going to do that for the sake of explaining how we got the graph. So this gives us negative t cubed over, what is that? Over 12 plus 4t plus the initial displacement plus 0 meters. So I want to like make sense of how we got that graph answer. So the answer
Yeah, but
was
like you don't have to do all this.
no, you don't. But this is actually what you could figure out and verify. Let me.
Bro, I'm sticking with the bum way of doing it. I'm not gonna
Yeah, no, I know, but
lie.
it also says it's in the positive direction. And it's located plus 8 meters from the origin.
Yeah,
So
you
that's
can just
actually what our
cancel. You can just keep canceling out what's right and wrong.
yeah. So this is plus 8. Okay. So when we graph this plus 8, we're gonna get this answer here. We're gonna get that when we look at just this right half. So that's how we got that answer.
T can't be negative.
Yeah. So that's the
Yeah,
initial
but
display.
you
C
could
can't be
also just
negative.
look
C
look at all the answer choices.
yeah. Well, some of these don't
How
make
many of them
sense.
start
All
with
right.
like
So
something that's
next it
relatively
wants to
positive,
know the car will come
have
to
a positive velocity, and then change direction? Or
Next, it wants to know the car will come to instantaneous rest when t is equal to. So we found this function v of t that represents t with respect to time. Rest just means velocity is 0. So 0 meters per second is equal to negative t squared over 4 plus 4 meters per second. When we solve this, when we rearrange, you get 16 equals t squared, 16 meters per second or whatever. No, that's not meters per second. Okay, whatever. So 16 equals t squared, so t is going to be equal to 4. Time will never be negative. Scalars generally won't be. But velocity and everything else could. So t equals 4 seconds. That's how you get that. You set the velocity function we found by integrating a of t with respect to time. You set that equal to 0 because
yeah,
that's
bro, I
what
didn't even think to integrate, so like this is actually
yeah,
helpful.
because so most people made the biggest error, the absolute largest error, was that most people use this equation. But all three, what's really important to understand, all three of these equations, they only work when you have constant velocity, constant acceleration, constant time. As soon as they become a function of time, none of this all goes out the window. So you have to remember your identities. Acceleration is the derivative of velocity. Velocity is the derivative of position. So if you want to find position, you integrate acceleration twice.
You know how like half of the more kids would know to do that? Go back to the problem.
How they would know to do that?
Yeah.
Um,
If he just put the of t on the damn thing, f of t, I feel like people would realize that.
maybe.
Like that's all it takes, bro. Then we know it's a function of t. Like that shit was tripping me up for a good minute.
Yeah. No, I know. I think, but
It
it's
did
just
say by the function that, but like
it's
I'm
implied
stupid, bro.
given by the
I
function
don't
f
I,
of
I don't
t.
read
Yeah, no.
mathematical
For
words,
physics, like
bro.
the little words do make a big difference, so I find that to be really helpful.
Like I'm dumb as shit,
Where's
bro.
the rest of the Carmen homework? I believe it says a page, Brian. I think it's like 284 or some random thing like that. You have to find it on the Stewart textbook. Um, do we want to wrap this up or something else?
Commentary.
What happened?
I just want to know what Connor's predicting for this test Thursday. 100. Yeah.
My predictions for me,
Mhm.
uh, maybe like, oh, there's probably gonna be a
7.
curve. Maybe like almost 80.
Yo, 6-7 pre-curve is my prediction for you. I have faith in you.
Wow. Thank you. Thank you.
That's like a good grade for you, bro. Not gonna lie.
It is.
Wait, what even is that, JT? Do the math real quick. Square root 6-7 times 10.
What?
It's gonna be
Do
like
you want me to uncurve it or recurve?
no,
That's an
just
81. That's
6-7
82.
pre-curve.
I don't know. Okay, what else do we want to... What was... Let me look at what was hard on this test.
I feel like honestly,
Quiz.
the only kids who are gonna do bad on this test are kids who didn't take one. and are dumb.
The Atwood machine did trip me up a little bit at first.
What if there was an
Wonder who
Atwood
that is.
machine with tension? Like
There's always
also
tension in
points
the
one.
Atwood machine. That's the
No,
whole
no,
point.
no, no. Like with I don't even know, gay. I'm cooked.
Let me actually like open it because I think that trips me up a little bit.
Those are like annoying, but like if you're sitting on the test and you're actually thinking about it, they're not that bad.
Yeah, well,
The problem is
I
when you
do
do
think it
AP
trips me up
classroom, like
though.
your brain literally just freezes because you don't. It doesn't count for anything.
Um,
This is just me
all
who
right, block
agrees.
K and L were initially. Oh, it's wrong question. The swing shown is attached to the rope. Okay.
That's
Yeah.
good. That's an easy question.
Okay, yeah. I feel like this tripped me up the most of anything. Open the left and right.
Wait, what? The swing?
Yeah.
Why?
So
It's just
well, okay.
both
So the tension on the left and right are gonna be um
equal.
equal. Yeah. Yeah. And what
You
else?
know it's equal because it says the left and the right. Wait, no, it says remaining in equilibrium.
Yeah. Um. Yeah. I don't know. There's
Bro,
not much to
the
that.
amount of smart kids who got that one wrong is actually crazy, bro.
If it asks you to solve, if we were to flatten this system right into 2D, um, what's really interesting is, so if we were to flatten this over the circle, right? Um,
What do you mean flat?
when you flatten a system, you're looking at it as if it were a 1D problem.
Oh, like when we do that with
So
the
we have,
Atwood machines usually.
yes, this is an Atwood machine. TR is tension to the right
Wait,
is
what?
pulling upwards.
It's not
T
an Atwood machine.
TL, and then the mass of the person at the end of the swing, F FG, is going to the right. But what's also interesting is his hands are actually, if you look, his hands are pulling the rope down. So there is actually force of gravity affecting this. Technically, it's the force of the arms, but part of force of gravity is pulling that down as well. So that's something to.
Well, FG equals 2T.
But it would depend
No?
on how much he chooses to pull it. Like he could choose, and that would affect the balance. It depends on how much his arms exert. So we couldn't really easily numerically solve this without knowing like the biomechanics.
So this is a bum ass question.
It's good for like a free body diagram, which is what we had. So
No, but like whoever wrote it didn't really think of the intricacies of it.
which it's just of the child and the swing. Yeah, so both tensions were pulling up, but the weight was pushing down. That's if you don't flatten it. Because flattening it does, you usually flatten it when you want to numerically solve. But no, I think this was a good question for a free body diagram.
So what are we getting on Thursday?
Who's we?
We, like me and you, are getting the same grade. So
We're getting the same grade. Well, then I better like take the test with my eyes closed.
yo, chill. I got a 95 on the quiz. I feel like that's like you could get a 95.
That's solid.
Yeah, you got 100. You and Davo, probably the two kids got 100.
What's a night? What is that? 90. Nice.
That's two MCQ though.
Carmen.
Yeah, I'm not gonna lie. The FRQs were mad easy, but I feel like that on Thursday it's gonna be way harder because
Well, we're
AP
not
class.
having experimental design to work energy power. I don't think Donahue's done experimental design.
Bro,
Right?
experimental design is one of the most AIDS thing of all time,
I
bro.
don't think you've been. Oh, you haven't done them for physics too. I think it's arguably.
It's actually the worst thing ever, bro. Like, what are we doing?
Yeah. Well.
Like, I'm when I see that on the AP end of year and it's like E and M, bro, I'm just giving up.
All right. Are we done for the night?
I mean, can I send you questions like tomorrow if I'm retarded?
I'm not gonna answer my phone during this school day. Never.
No. Tomorrow, like,
Yeah.
like after school, before, no, like
That's fine.
before the test or something.
Yeah. Yeah. Whatever.
All right, John Thomas, my goat.
All right.
Appreciate it as usual.